Good day. You know by now that rational numbers consist of fractions, where a over b and a and b is element of integers and b should not be 0. And you also know, because from our discussion, that recurring decimal numbers are also rational numbers. And for recurring decimal numbers to be able to be rational numbers, it means that we should be able to write them as a fraction. For example, 0,3333 recurring is the same as a third. How do I know that? Let me show you how we can determine this. Let's do this as an example. Right, example 1. The first thing is, make your first step equals to 0. Not 0 to x. So I will have x equals 0,3333 and so on recurring. And I'm going to name that equation 1. So on the right-hand side of my comma, I only have the recurring part. Now, for the next step, have one of your recurring patterns on the left-hand side of the decimal. So I would like to have 3,333 and so on. But how did I change it from 0,33333 to 3,33333? What did I do? I multiplied by 10. And then you are going to do it with the x as well. So I will multiply by 10. And 10 times x will be 10x. And we can say that this is my second equation. Okay. Now, very important, I have one equation that consists only with the recurring part on the right-hand side of the decimal. And I have another equation that has one pattern on the left-hand side of my decimal. So what do we do next? Now we are going to get the difference between this. So we're going to say equation 2 minus equation 1. So on my right-hand side of the equal sign, I will have 3,3 recurring. You remember that if we write a recurring number, we put the dot on the recurring part, minus 0,3 recurring. But I need to do it with the x part as well. So on the left-hand side of my equal sign, I will have 10x minus x. Now, boys and girls, if you say 3,33333 minus 0,33333, then it means that the part behind my decimal, or the part on the right-hand side of the comma, will fall away because I'm subtracting it. It becomes a 0. So I would say 3,33333 minus 0,33333 will end up by having an answer of only 3. Now, on my left-hand side, 10x minus x is 9x. Get your x alone. Divide by a 9, divide by a 9. So x equals 3 over 9. But I would like to have it in the simplest form. So what number can go into 3 and into 9? Yes, I can divide both of them with a 3. So divide by 3, that will go into that once, and 3. So x equals 1 over 3. And can you see now that my 0,33333 recurring is the same as a third? So yes, I have proven that the recurring decimal number is also a rational number because I can write it as an ordinary fraction. Let's do another example. Example 2. A number of 0,989898 and so on. That is my recurring number. So what's your first step? your first step will be to make that equals to x. So I will say x equals 0.9898 and so on, and I call that equation 1. Now, the second part is I would like to have a recurring pattern, or one of those patterns I would like to have on the left-hand side of the comma. What is the recurring pattern in this case? The recurring pattern is 98. So it's 0.98989898. So I would like to have a 98 on the left-hand side of my comma. So 98, 9898, and so on. So to have changed the 0.989898, etc., to become 98.989898, what did you do? I've moved the comma 2 places, or you can say I've multiplied by 100. So this I've multiplied by 100, and now I need to do it with my x part as well. I'm going to multiply by 100. So 100 times x will be 100x. And this is equation 2. And once you have an equation that has the recurring part, only the recurring part on the right-hand side of the comma, and you have another equation that has one pattern, recurring pattern, on the left-hand side of the equation, then you can get the difference between these two. We are going to subtract them. So I'm going to say equation 2 minus equation 1. Because we would like the recurring part to fall away now. So I have 98.98 recurring minus 0.98 recurring. I did that on my right-hand side of the equal sign. Now the part on my left-hand side. 100x minus x. Okay. What is 100x minus x? It is 99x. What is 98.98989898 minus 0.989898? You can see that the part behind my comma, the recurring part, will fall away. So the answer is actually 98. And to get your x alone, divide by 99, divide by 99, and my answer will be 98 over 99. And if you take your calculator and you type that in, 98 divided by 99, and you press the SD button on the scientific calculators, you will get an answer of 0.98989898, and so you can actually check yourself. I do hope that this makes sense to you now and that you will be able to change recurring decimal numbers into ordinary fractions. Until next time, goodbye.